In this video, I'm just going to go over how to solve a system of equations using a TI-84. So first, let's say you have the following system of equations. So the first step is to rewrite each equation in the following form. So basically, you just want a constant times x1 plus a constant times x2 plus a constant times x3 equals a constant. And you want each equation to have this exact order of variables where all of your x's or all of your variables are on the left and then set equal to a constant. So let's put them in this form. The first equation we can write as 5x1 minus 2x2, and then that 3x3 is on the other side, so we can subtract it over. Set equal to a constant, so we need to put that 24 on the other side. Boom, that's the first one. Now the second one, we can just add that 4x1 to the other side. So 4x1 plus 5x2. Now we don't have an x3 in this one, so we can just say plus 0x3. And we don't have a constant, so it's set equal to 0. Now the final equation is just 6x1 minus 12x2 minus 8x3 equals 0. All right, and that finishes rewriting our equations. So now what we're going to do is we're going to take this system of equations and convert it into a matrix. So the way we're going to do that is just by creating a matrix that only uses the coefficients of each equation. So for example, we're just only going to look at all of these numbers for each equation. So we can make our matrix. The first row will just be 5, -2, -3, 24. Then we do the same thing for the other two rows. 4, 5, 0, 0, 6, -12, -8, 0. So when we look at the TI-84, we can see this matrix button in blue. So we're going to do second matrix, and then you're going to go over to edit, and then enter. And then you need to select the size of your matrix. Now, I already have it set to 3x4 because we are solving 3 equations with 3 variables. And since we have that constant over there, that's why it's a 3x4 matrix, because the 3 represents the number of rows and the 4 is the number of columns. So if you're trying to solve if you have 4 equations, 4 unknowns, you'll need a 4x5 matrix. If you only have 2 equations and 2 unknowns, you'll need a 2x3 matrix. So our case is just a 3x4. So now all we're going to do is we're just going to plug in all the values that we have in our matrix. Okay, so after you've done that, you can quit out of it, and then you can go back into second matrix, and then you're going to want to go over here to math, and then you're going to want to scroll down until you find RREF. Now that stands for reduced row echelon form, and you don't need to know the details of it, but you're just going to click enter on that, go back into the matrix, select your matrix A or whichever one you used, and then just press enter. So this reduced row echelon form of A basically just spits out an equivalent matrix. So if we were to write out what this matrix really means. If we take it back into equation form, we'll have the following equations. And if we simplify this, we can easily see that it is saying x1 equals 32, x2 equals negative 25.6, and x3 equals 62.4. So basically, every time you do this reduced row echelon form with the matrix, you can look at the calculator and say, okay, whichever variable you used for the first column will just be equal to, for example, like here, 32. Like we know x1 is 32, x2 negative 25.6, x3 is 62.4. So you can use this anytime to speed up your calculations, and that should be very helpful, especially for circuits.